Okay, we begin Chapter 8, which deals with square roots, also known as radicals. And it's a very easy chapter, but there's a lot of ways you can get your wires crossed and have a little bit of a tough time too. Now we begin by saying the square root of 25 is equal to 5, and that is because 5 squared is equal to 25. And after we ask that question, we then want to ask another. Can the square root of 25 equal negative 5 also? And the answer is a definite no. And the reason is, by definition, and I'm writing this out because it's so important, only a positive can come out of a radical, can come out of a square root, I'll say. Result from a square root. Now, there are different types of root, so I specify square roots in this case. After we ask that question, we then want to know what is the square root of negative 25. And the answer is that does not exist. And I'm going to qualify that also, saying it does not exist using real numbers. In your next course, you will then develop what we call imaginary numbers, in which case we will have a solution. Now, if you think about it, when we're asking what is the square root of negative 25, we're asking what number, when multiplied by itself, makes negative 25. And since a positive multiplied by itself results in a positive, and a negative multiplied by itself results in a positive, there's no number that when multiplied by itself makes a negative, and that's why this solution does not exist. Now, the answer to this next problem is negative 5. And I'm not violating what I've set up above, even though I have a negative answer, because it's the original negative out front, negative 1 times the square root of 25, that comes out as negative 1 times this answer of 5, and so I'm not contradicting myself in this case. When we are asking to find the cube root, and this is a cube root because that number in this position here tells us so, that number is called the index. When the index is 3, that says we have a cube root, and that says, or our answer here will be negative 2, and the reason for that is because negative 2 to the third power is negative 8. Now, you are allowed to have negative answers when you have cube roots. You're not allowed to have negative answers when you have square roots, as we have in the problem before and the problem after. So that's something to be very careful of, watching out what this index is. And even though we don't write it, there's an understood 2 index on any square root. But just like we don't write a 1 in front of an x because it's an extra symbol that we have to write, we don't write the 2 inside the square root symbol because the index is assumed to be 2 unless we write otherwise. Now, when we move on to the square root of negative 8 squared, I know it's tempting to say that the answer is negative 8, and the reason it's tempting is because we want to think of the square root undoing the square, and you think, oh, out pops my negative 8. But the answer is not negative 8, it's really the absolute value of negative 8, which is positive 8. If you want to think of this instead as equal to the square root of 64, then equaling the 8, that's fine also. But whatever comes out of a square root must be positive. And that leads to this next property. The square root of x squared, you might think, is equal to x. But it's not equal to x. It's equal to the absolute value of x. Because the variable x sitting there on its own without the absolute values can represent both a positive and a negative. And we need to ensure that it's positive by sticking those absolute values on. So, in a way, squaring and square rooting are not exactly opposite procedures because of this absolute value in the property. Now, quite often your book or computer program that you're using to work with is not going to require the absolute value. And what will happen in that case is there will be a disclaimer next to the problem saying, assume all variables represent positive values. And in that case, you don't have to worry about inserting the absolute value. But if that set of directions is not there and it doesn't say to assume the variables represent positive values, then you need to, on your own, insert the absolute values. Okay, let's move on to a few examples here. The square root of 100 is equal to 10. You should have many of your perfect square numbers memorized. 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144, which leads us on to this next problem where we know the 144 square roots into a 12, and the square root of the x squared comes out as an x. But I don't have any disclaimer next to these problems, so I would have to be careful to write that as 12 times the absolute value of x. Now, if we think of the absolute value bars as jail bars, then you might say, oh, I don't want to send anybody to jail unless I have to. And that's kind of what's happening here. Only the x goes inside the absolute values, not the 12 along with it, which in this case they'd be equivalent to each other, but we only want to stick what we just have to into the absolute values and nothing more. On problem number 3 here, the square root of 225 is 15, and the square root of w to the 4th is w squared. And that's because w squared times w squared makes w to the 4th. This time we do not consider absolute values because anytime we have something squared or raised to an even power, it is positive already. It's only terms that are to a first power or to an odd power that we don't know whether they're positive or not, and thus would need absolute values. On the square root of 169, that is equal to 13, and the w to the 6th square roots to w to the 3rd. You can, it is correct saying, you can cut that exponent inside in half, the 6 cutting in half to give you that 3. Now, since this is an odd power coming out, we do not know whether this w to the 3rd is positive or not, and so we force it to be positive with absolute values. The 4th root of x to the 4th is also going to be the absolute value of x, because whatever comes out of an even indiced radical must be positive. So the question you then ask is, when exactly do you use absolute values? And I'm going to give you a very specific rule. It's going to be when an odd exponent comes out of an eventh root. Now, by an eventh root, I mean an even indiced radical. The word eventh is not a word that you can use in a Scrabble game, kind of one that I've made up myself. Now, I know this may seem a little bit scary. Most books do not deal with absolute values in an introductory class, but I want to let you know about these absolute values here. Odds are you're not going to have to use them very often at all, because there will be a disclaimer in your problems saying assume all variables represent positive values.